here. Page 22 are word problems with exponents. So one of the places that exponents come into play with an application is in the surface area and volume of a shape. Pencil?
How many classes are we behind?
We're getting closer. I'll have to check with the other grade 9 teachers to find out. I feel like we're only like a couple classes behind right now.
No, one of them were ahead because they haven't had it.
They haven't had tests for powers yet? Okay. Yeah, we're going not too bad. Surface area. Now, surface area is the area of all the surfaces. And when we talk about a surface, that's the part along the outside. Does it make sense that if you had a cube, that it has, and here's a picture of one, or here's an actual cube. So, here's a cube. This cube that I have that you're looking at has different sides. Some of them painted gold, some of them painted silver, some of them are painted maroon, and some of them are painted violet, okay, and blue, okay? If you painted all the sides, how many sides do you have to paint? Count them. 6 of them, right? So for the surface area, for our surface area, we have to think about it being 6 squares. Because if we have 4 centimeters here and 4 centimeters here, the surface area is going to be 6 of those squares. And since area, you know that area is the amount to cover a 2-dimensional size. It's going to be like length times width. You remember learning that? And so if you had 1 square, would you agree that 1 square would be 4 times 4? Area of 1 square is 4 times 4, which we could write as 4 squared, which is 16. I know you get so excited about writing 16. And this is why surface area questions are in the exponents unit, because you could write it as 4 squared. Okay? But you could have done this question before the exponents unit because you know about area. And so our total surface area, if it's 6 squares, would you agree that it would be 6 times 4 squared, or 6 times 16, which is 96. That's not bad looking 6. 96, and since our units are centimeters, we have to include centimeters squared. Circle that. That is our surface area. Now I'm going to switch colors to do volume. Do you know the formula for the volume of a prism? Length times width times height. And that makes it 4 times 4 times 4, which in the exponents unit you could write as 4 cubed, which is equal to 64. What do you think our units are going to be for volume? Centimeters cubed. Oh, I've actually got, just luckily, got these little squares the other day. They're red. You can hold them. That'd be fine. Here we go. Okay. These are designed to be perfectly 1 centimeter, and there's 10 of them stacked. So if you look at them closely, they got lines. Each of these is exactly 1 centimeter cubed. So when we're talking about having 64 of these, this is 10. I would have to have, I could even grab another 5. This would be 60 of them. There we go. And 4 more. Okay? Now, something very cool about centimeters cubed. Just applications to all sorts of things. Okay? 1 centimeter cubed, if you would take it and it had a little hollowed out and had a little pitcher of water and poured it in there to fill up one of these, 1 centimeter cubed is exactly 1 milliliter. So if you had 64 centimeters cubed, which is about what I have here, that'd be a pretty tiny drink box. Okay? 64 mils is not very big, right? Like what is those small drink boxes that you buy, I think, are what, 200 mils? Right? They're like a little bit bigger than this. Okay? If you buy a 1 liter drink, it would fit 1,000 of these little squares in there. And when you get, when you get your COVID shot, they might say you're getting 5 cc's. Sometimes you'll hear them say that for how much of the shot you're getting. 5 cc's, the cc stands for cubic centimeters. That means they're giving you 5 milliliters. They would give you, that's actually quite a lot of medication if they were giving you 5 milliliters. So it just gives you a perspective of how big something is. Look at that. Just found these blocks the other day, and now I have a use for them. So good. Okay. Oh, the circle. I colored your circle in the same color I colored, yeah. So right beside it, you can attempt to draw a circle inside the square. Here's a new word for you, inscribed. When you inscribe something, its edges are touching the edges of the other thing. So it's not just any circle, but these corners should touch perfectly. And we need to find the area that's left. They're not triangles. They're kind of triangle-looking-ish, but they're not perfectly triangles. Yes. So here is the idea. And this is how you solve problems. You come up with the idea first. If you take the area of the square, I'm going to put that in brackets, and you subtract the area of the circle, okay, then you will get what's left, which is the shaded part. I have good news for you guys, if you're forgetting these formulas, is that in grade 9, there is a formula sheet. And you will be able to use it on the test or on the quizzes. And on the formula sheet is a circle that's drawn, and it has an area for, it has a formula for the area and a formula for the circumference. It also has a picture of a cube, and it has the volume formula and the length times width times height. Yes. So I'll hand those out. I will give you, maybe I have enough copies right now. I'll give you your own copy. No, I have enough to give them out now. So I'll give out your own copy now, and I just might have to hole punch a few of them. Here, I'll hand you those. Those hole punched? So, nice and colorful. Here's a hole punch. I've got more here if that's not enough. So we have a formula for the area of a square. On your formula sheet, it says S squared. What do you think the S stands for? For the area of a square. What do you think they mean when they say S squared? It is the side, which is 20 centimeters, side squared. And then we're going to have to minus the area of the circle. And on your formula sheet, it says the area of the circle is pi r squared. And so the formula sheet is helpful if you know what the letters stand for. So if you thought that the S stood for circle, which is a really bad thing to think that it stands for, because circle starts with C. But yes, if you thought the S stood for circle in the formula, it's not going to work out well for you at all, right? The S stands for the side length. Do you know what the R stands for in the area of a circle? What? Round. It is the radius. If we draw the radius on your, how long is the radius? 10. Because it's 20 all the way across, the radius would be 10 centimeters. So now we can plug things into our formula, and this idea of substitution that we've done before comes into play now. So here, this will be 20 squared minus pi, and the radius is 10. Remember, when we substitute numbers in, we put them in brackets to help us just hold that number. And 20 squared is 400. And 10 squared is 100. So if you were doing order of operations, you would do that 100 first, and it still needs to get multiplied by pi.
I'm confused. Why is there still a squared side? Like after you already squared the 5.
I never squared any 5s. The radius is equal to 10, and I just plugged it in. And now we could go to our calculator and do 400 minus 100 times pi, and we're left with 85.84. I type this into, and this is the area of the shaded part. Yeah, and yeah, 3.14 times 100 will be approximately 314. I used all the decimal places, right? Because this you would have to do on your calculator 100 times pi. And what are our units going to be since it's area? Centimeters squared. Okay? If you forget your units in a word problem, you always lose half a mark. Okay? You have to have centimeters cubed for a volume question.
Like ml or centimeters?
If the question was in centimeters, you would write centimeters cubed. Okay? Okay. Everybody ready for the next one? Find the area of the square that is attached to the hypotenuse of that triangle.
Oh, I remember doing this in grade 8. I remember doing it. I don't remember how it
is on your formula sheet. Do you see that a squared plus b squared equals c squared is the very first formula? Does it make sense that first, I'll draw a green line here. First, you need to find the hypotenuse. How do we find the hypotenuse? Well, it's on your formula sheet. A squared plus b squared equals c squared. And in this formula, the c squared is important because it is always your hypotenuse. So in this case, you would write 5 squared plus 12 squared equals c squared. 25 plus 144 is 169. And then how would you get c by itself? You would have to, how do you get rid of a squared? Opposite of squaring is square rooting. So you square root both sides, and we get c is equal to 13. And once we figured out this side is 13, area of the square would equal 13 times 13, which is 13 squared, which is 169. Was there any units given in this one? No. So we don't have to include our units. Sometimes people like to do this, units squared, just to make sure that they haven't forgotten. Oh, that were not part of it? Okay. I'll stick them at the bottom. Transitional math 1. And formula sheets. And most of them are clipped together. All right? Look at that one.
One of these days, I'm going to have to look at on the next thing. I'm going to help you organize.
Help me organize? It is very organized. See? That's a great organization. Throw it in, put it away. Sorry? This is on your quiz tomorrow and on the test, yes. We have a quiz tomorrow. That's why at the beginning of class, we did this. Okay? You remember that. Next, applications to biology, bacteria. Yeah, no, we're not doing the meiosis part. Question? You may. Okay. There are lots of things that double quickly, and they use exponents to discover and to study this. One of the examples is viruses. Viruses can double very quickly. That's why COVID was so scary, because if we didn't do things to hold it in place, it might double every 2 days. And if something doubles every 2 days, it's not so bad at the beginning. Oh, 2 people have it. Oh, 4 people have it. What's going to happen in 20 days? If you double times 2 in 20 days, do you know how big a number you get? Let's see. You're already at over 1 million people in 20 days. And you're like, oh, it's no problem, because in day 2, we only had 4 people. Right? Day 3 is 8 people. Day 4 is 16. It doesn't seem so bad at the beginning, but when things double quickly, they get out of control quickly. And that's what made governments and doctors so afraid about COVID. Don't say that word, right? Okay. So what do we have here? We have bacteria. Bacteria, same thing, doubles very quickly. So a little bit of science. The growth of bacteria is caused by a process which causes the division of cells. It divides and becomes 2 cells, hence the doubling. Okay? growth of bacteria will continue to double, and for this reason we call it, and you can underline this, this is called exponential growth, because it has an exponent involved. Okay? So here's what they were looking at. At 8 o'clock, there was 500. And every hour, it doubled. So it started with 500. At 9 o'clock, there was 1,000. At 10 o'clock, it doubled again, which is 2,000. And so what's happening is every new number is just the previous number times by 2. Do you see how the exponent is starting to come? Because if you thought of the previous number, instead of writing it as 1,000 times 2, you said, hey, it was 500 times 2 again. And then this one is 500 times 2 times 2 again. And we start to have an exponent. After 24 hours, you would have this. Can you see that after 24 hours, what has really happened is that you have doubled how many times? 23 times. Does that make sense? Because if you, after 1 hour, you've doubled, oh, wait a minute. It is 24. After 1 hour, it says after 24 hours, not. Okay?
Well, because actually then that's a big part, because after.
This is an important, if it said at 24 hours, then you would have 23 of them.
Why?
At 24th hour, it doesn't mean that 24 hours will complete.
23 hours. It gets really, the wording gets complicated.
Can you just say after 24 hours on the test?
I will. Okay? This is a huge number. That's why scientists write it as a power. Oh, look at this. And just, uh-oh.
It'll be 500.
Oh, too hard.
You got it.
A little harder, a little harder.
Put it there.
So good.
The YouTube will never know.
Yeah, they'll never know. Did you know you can make the fun thing about smart boards? Okay, we'll do our formula first, and then I'll teach you how to make a mini golf course on a smart board. Formula for the population would be population, well, you start off with 500, and then you times by 2 to the, and sometimes they'll use a letter like T, where T is the number of hours. When did we start? After what? Number of hours after 8 o'clock. So we have to create a formula. So if you wanted to find out how many bacteria there would be at 2 o'clock in the afternoon, what would you plug in for T? How many hours after 8 o'clock is 2 in the afternoon? 6 hours. So does it make sense that you would have 500 times 2 to the 6? So our exponent in this formula is very important because it gives us a way of showing how many 2's we would need. So here is another word problem. But this one's doubling, not bacteria, even more distressing. Okay? At this point, though, okay, seriously, it's -5. There's still snow on the ground. Do you know what's going to happen on Wednesday and Thursday?
Snowstorm.
Yeah, but not just, you say snowstorm, it's the worst one you've ever experienced. There's, for anybody, oh, yeah, like, they say it could be as bad as the snowstorm in 1997. Now, none of you were born in 1997.
Yeah, it's the worst.
Okay? But were you in Manitoba in 1997? I was in Manitoba in 1990. Now, the difference in 1997 in April. Question. Yes, they're saying
Looking at a snow day. I had a
there's not. It's not for sure. Okay. What I read this morning on an article is it said, do not travel. Make sure you're stocked up on food. There's a good chance that you could be out of electricity for a couple of days.
What? No Wi-Fi. That's when the data gets drained.
Okay. Now, this might not happen in the city because cities are more protected than if you lived in the country. But it could be that bad. We don't know. We'll see. But as far as comparison, okay, in 1997, the difference in 1997 is in April, they had a better spring than us. There was no snow anymore. It was like, it's spring. The grass was green. We were all ready for spring. When the blizzard hit, there was more snow in the ground after the blizzard than there was from the entire winter that year. More snow in 2 days than that entire winter. There were snow drifts taller than me in one blizzard.
I have had that in my life.
So we'll see. We'll see if it's as bad as they say or if it's going to just be, oh, it misses us,
And
right?
in Yukon, there was a record-breaking minus 66 day. Where if you were out, the news was that if you were out for longer than a minute, you could get frostbite.
Oh God.
Wow.
That's never no.
Any open skin for longer
Yeah.
than a minute could be frostbite.
That's right. Don't lick the air. That's what they said.
Imagine now putting your tongue on the pole.
Oh. All right. Okay. So at this moment, we actually might like to slap a mosquito. It's sort of like in the middle of summer, you're like, oh, I wish winter was here. And now we're in the middle of winter and we're like, yeah. Mosquitoes, please. Okay.
I heard birds chirping this morning.
Yeah. They're like, get away, it's coming. That's the translation.
Yeah, the geese came in and then they're like, nah, we going again.
So if you're solving these questions and you're a little bit unsure of what there are, make a chart, okay? So time in week 0, we can put this in brackets, this is weeks. Mosquitoes, how many did we have? 100 of them. How much would you have after 1 week? 200, because it's doubling every week. How many would you have after 2 weeks? 400. So you could make a chart. 3 weeks would be 800. 4 weeks would be 1,600. So you could, and you need your units. Our units this time is mosquitoes.
I get this one more than I get the bacteria.
Okay?
Bacteria one just doesn't make sense.
What would the formula be for mosquitoes? Mosquitoes equals, we started with 100, and we're doubling, so it's times 2 to the t, where t is what? The number of weeks after the initial population. So how many would there be after 3 months?
Well, you can't actually know what month is it.
Well, that's true. So we'll just say on average, 3 months is a quarter of the year. There are 52 weeks in a year. If you do 52 divided by 4, this would be after 13 weeks. So this is where our formula is going to be nice, because you don't want to keep making your chart, do you? You could, but the formula is nicer because it's less to write down. So we go to our calculator, 100 times, I'm going to go with, man, this is, does it start with a 9?
I don't know, I didn't do it.
Oh. No, it starts with an 8. We're going to do our mental math here. I'm going to say 819200. Is it 819200?
That's kind of crazy.
Yeah, that's right. All right. And we have to make sure we have our units. 819,200 mosquitoes. Right? That's why Winnipeg only has 1 month of summer. They're exercise. It's your like arm movement. It gives you good movement exercises because you have to slap your ankles. It's like this is how what's that style of dance where they do this? It's all because of mosquitoes. Is that Scottish Highland dance? Do they? I don't know. How many weeks would it take to arrive at 12,800 mosquitoes? So here's our formula. We have our formula, and we're told there's 12,800 mosquitoes. So we can plug in 12,800. Would we plug it in for the M or for the T? Yes, 1200, 800 equals 100 times 2 to the T. We divide both sides by 100. And we would get 128 equals 2 to the exponent of T. Now you're going to have to do a little bit of guessing and checking. Okay. Tomorrow, Finley, tomorrow is a math contest. Can I give this one to your brother as well? Okay. And you also missed a quiz on Friday. Can you do that at lunch today? Okay, perfect. So, you're going to have to do a little bit of guessing and checking with your calculator here. What number works? It's not square rooting because it's an exponent. In fact, you'd have to use, if you wanted to use a button on your calculator to make this work, you'd have to know how to use logarithms, which you learn in grade 12. Grade 12 pre-calculus. Yeah, I know. Seven. Sorry, that's a bad-looking 7.
Wait, what? Just 7? How did you figure that out?
I tried 5, wasn't big enough. I tried 6, wasn't big enough. Actually. Yeah. I actually lied. I didn't guess because I already knew. But that's okay. That's what you would do, right? You would keep guessing until something worked. So, again, this is a word problem. We would lose some marks if we just ended like this. We have to write a statement. It would be 7. What's our unit for the time? In this question, it's weeks. It would be 7 weeks after. Yes. Going to lose a half mark for not including your units. Question. Yes. Okay. Yeah. Because time, the T in the formula, stands for the weeks after the initial population. And since it's a word problem, we need to write a statement in the end.
I didn't know.
Is this making sense to Kale? Is this stuff making sense? Okay. Okay. Ooh, another doubling one. This time it is LJ. Ooh, again, missing summer. You guys, once it gets warm, you could go to Lake Winnipeg. Go in when it's all green and goopy and come out that LJ. Yeah. Okay. Ooh. Okay. So, a little patch of LJ doubles every month. It says that in 6 months, the entire pond is completely covered. The question is, how many months would it take to cover half of it? And this is where if they put this on IQ tests for people going into university, and a lot of people going into university get this wrong. It is 5 months. Does that make sense? What do you think most of the university students who don't think about this, they say 3 because they think half, they just take. Yeah, if you think about your chart, oh, I don't like this. Here we can put the month, and here we can put total covered. And at 6 months, all of it's covered. And if you're doubling every month, how much is covered in 5? Half of all, which would be half. So that's why it takes only 5 months. Can you see how you would think maybe 3 months if you weren't paying attention to the question? And that's why they put this on IQ tests. And that's why they put it on university entrance tests, because they're checking how many students paid attention in grade 9 to what doubling does, or are you mistaking doubling with multiplying? They're different. Yeah, let's do a frog question. Yeah, just you imagine we shut the door and we start with 100 frogs in here.
My brother killed the frog, so he had to fry it up. Nobody killed it back.
Okay.
So he kept it in my pan, fried up on a barbecue. He's fried.
I know.
So you know how to cut a frog? He was like fry. He was like 7. Like traumatized.
We're going to add the word after in here.
Well, I already know the answer.
Okay?
Dad has weird ways to teach us lessons, okay?
So, if you made your chart after number of years and frogs. At 0 years, you start off with 100 frogs. How many frogs would there be after number of years? That's not really good English.
I know the answer.
How many?
10.
No, it's tripling.
50 years will be too much.
Yeah, but you're tripling, which means you're timesing by 3. So after 1 year, there would be 300. After 2 years, there would be 900, because you triple again. Dot, 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 it keeps going. It would sure be nice if we could make a formula. Frogs equal. You started off with 100, And then you're tripling, so your base will be 3. After the initial population. Why is that formula really nice? Because now when we solve these questions, we could keep going with our chart, right? But this is nicer because we can say the frogs is going to equal 100 times 3 to the 5, which is 300. That is right. And what do we have to add? Our units, which is frogs. Froggies. Yeah, I won't be able to do the 51. The 10 one, even, will be too big for me. 10 is huge.
You can do 10.
I don't think I can do 10.
Now you can.
No.
You lucky you did the other one.
Oh my goodness. I'll just estimate. Can I estimate it?
No, you have to get an exact or you're not a good math teacher.
Okay. All right, I'll just do some mental math here.
Yeah.
All right. You guys can go if I don't get this right. This might take me 4 hours. But you'd have to stay for 4 extra hours. You miss your lunch hour.
Oh, we wouldn't make it.
Oh. No, I would get you excused. I'd quickly write an email. My students are waiting to see if I can calculate this.
Hey, whoa.
So, I'm going to go with and there's more numbers? Then 900. Frogs. We can't have 0.2 of a frog. If you do, that's not a happy frog.
Let's see that 50 years. Why don't you just do that times 10?
No, it's not just times 10 because you're multiplying by 3s. This is going to be a frog apocalypse here. A frog. What do they call that when there's like a infestation of frogs? A frogalypse. Sure. So powers get very big very quickly. This one, when you type this into your calculator gives it to you with a 7 as a decimal, and you're like, why is there a decimal here? So if I round to 3 decimal places, but then it has a times 10 to the 25. Do you know scientific? And this one might have an e to the 25. Does that have? Yeah.
Does yours show like that?
Mine shows like the times 10 to the 25. Some calculators say e to the 25.
Now, we could have 2 decimal places, right?
2 decimal places would be 5. Do you know what this 10 to the 25 means? It means that technically, if you were rounding this, so 1, 7, 9, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25. That's approximately how big that number is. Yes. Holy froggies. Right? If you went for, if there was that many frogs, and you even ran 10 meters, how many frogs would you kill? Right? I don't even, you could, like you'd have to have, your cars would now have to have frog shield wipers. Right? It wouldn't be like, I would take the wind any day, but now the raining frogs. Right? You'd have to have You have your summer tires, your winter tires, and your frog tires. Because you know how hard it is to stop on frogs?
But when
No.
frogs reproduce in the winter,
No. This is why.
question is natural.
This is why blizzards exist.
This question
So
is
we don't
not-
have frog problems.
in the winter they won't reproduce.
Mm-hmm. There was a grade 9 math exam one year that asked this question, and students had never done it ever in their class before. And the problem is they would go, oh, I'll just do this on my calculator, but it's too many numbers for your calculator, and your calculator couldn't find it. So the first year they put this on a math exam for grade 9s, yeah, it doesn't even show up on your calculator. Because if you do 3 to the 51, it's like times 10 to the 24. You can't see the last digit. Your calculator doesn't show it to you. Okay?
And that doesn't mean it would be a zero?
It doesn't mean it's going to be a 0, because that's just an estimation. So the way that we would figure this out is we would look for a pattern. The E means times 10 to the 24. Yeah. Now, if you did 3 to the 1, you get a 3. If you did 3 squared, you get a 9. 3 cubed, you get a 27. And 3 to the 4, you get 81. 3 to the 5, you get 243. 3 to the 6, you get 729. 3 to the 7, what do you think the last digit of 3 to the 7 is going to be? 5. No, it's not going to be a 5. 9. It's going to be a 7.
Oh, it goes
3971. 3971. So the next one's going to be a 3. The question is, where in the pattern will you be when you get to 51?
Oh, and so that's your last digit.
Okay? A 48 would be a 1. How do you know 48 is going to be a 1? It's a multiple of 4. So we notice that all of the 4s, 4, 8, 12, 16, they'll always be 1 because the pattern has 4 numbers. 3, 8, 9, 1. 3, 8, 9, 1.
Is that only for 3s?
Okay? Yes, we'll find out for 7s next what the pattern is. So
Are you going to put other numbers in there?
it could be any number. Say? So the patterns are you going by 4s. 48 is a multiple of 4, and so 48 would end with 1. That means 49 would be a 3. 50 would be a 9, and this one ends in 7. Very few grade 9s got that question right on the exam the first year they put it because they didn't give any warning that they were going to put that question. No teacher had ever taught that. It was just like, hey, could you figure this
How
out?
did they get it right, though?
They didn't.
I've been in the
You said
And then, well, there are some people that figured out the pattern. There are some students that do lots of math contests, know how to solve questions like this.
Would you see this on an exam these days?
No, because what happened is when this was first on the exam, and everybody got it wrong, then every teacher started teaching it the next year, and more students got it right, but then it was on the exam again, so then more teachers were like, we really got to teach this, and then it was no longer a problem-solving question. It was like, you were taught this in class, can you do it? But let's do the 7 one just for fun. 7 to the 1 would be 7. 7 squared is 49. 7 cubed would be 343, I think. Is that right? 343. Is that where the pattern stops? No. 7 to the 4. 2401. And then 7 to the 5 is, there's 6807. How many times does it read? 1, 2, 3, 4. The pattern is still 4, eh? It's kind of cool. 7 to the 6 is going to end then with a 9. 7 to the 7 is going to end with a 3. And 7 to the 8 is going to end with a 1. So the pattern is 4 numbers. 7, 9, 3, 1, 4 numbers. So now you look at, that'll tell you since 28 is a multiple of 4, 28 is going to end with a 1. Ends in 7. Oh, this is,
I've never, 15 years like for these courses, I've never seen that tall.
yeah, because it hasn't been,
Will your calculator tell you everything else except for the last number?
yeah. Well, your calculator tells you fine up until it gets too big, and then it runs out of places to show you all the numbers. Well, once it gets too big, like let's see on my calculator, 7 to the 6, no problem. 7 to the 7, no problem. 7 to the 8, no problem. 7 to the 9, 7 to, no, you don't have to put the actual number. You just have to say what it ends with. 7 to the 10, I can go up to, on this calculator, I can go up to 7 to the 11 to see all the numbers. Then 7 to the 12, it doesn't show me anymore. Because it, okay? If you wanted to see what 7 to the 29 is, yeah, we have one more question after this. But if you go to the internet, there is a website called Wolfram Alpha. And Wolfram Alpha is the Google of math. When you go to this, you can do stuff like 7 to the power, use the little hat button, of 29. And it will actually show you the number that it ends in a 7. In fact, you could even do 7 to the power of 529. Oh my goodness. And it will show you all of the number if you wanted to see it.
So really all you have to do is cheat while you're on the test.
That's right, just Google it. Yeah, you'd have to show your patterns and stuff. Last question. We have one question left, and we're done our entire unit without a calculator. Which is bigger? Whew. Would 33s be bigger than 42s?
Yes.
How would you figure this out? Okay, I have another question for you. That's a little bit easier. Okay? I have 10 of one number and 10 of the other number. Okay? Which one's going to be bigger, the bigger number or the smaller number, if there's 10 of them? The bigger number. So if I had 16 10 times and I had 27 10 times, it'd be really easy for me to say that the 27 10 times would be bigger. Okay. This question is the same as this question. How did I do that? Why are these questions the same? No, I know, but this is exact same answers. This 16 to the 10 is the same as 2 to the 40. How did I do that? 27 to the 10. I did 2 with an exponent of the 4 to the, isn't that one of our exponent rules? Power to a power, that's our power rule. You multiply the powers, that would be 2 to the 40. So I could write this as 2 to the 4 to the 10, and I could write this one as 3 cubed to the 10. Oh, that's not equals. Which means this one is 27 to the 10, and this one is 16 to the 10. So which one's bigger? There's no equal sign. This one's bigger. Without a calculator, we could do that without actually having to figure out how big those numbers are.
What's the answer to that? What's 27?
27 to the 10 is too big to do in your head. It's 27 times 27 times 27 times 27 times 27 times 27 times 27, 27 times 27 times 27. My guess is more than 5.
My guess is.
So you have some homework tonight. Page 118 out of your textbook, 1 to 7. You have a quiz tomorrow. We have a test on Thursday, unless there is a blizzard so bad you can't come to school. Yeah. That's the, okay. See, look at that. That glint in the eye is the same glint in the eye when someone said, hey, we don't have to come back after spring break because of this new thing called the coronavirus. And there was glint in students' eyes. There was. I remember it.
But I regret it.
Yes.